Now that you've basically mastered the constant and power rules, we're going to look at the sum and different and constant rules. There we go. So if you have two functions who are being added together, you just take the respective derivatives of each of them. Same thing with subtracting. Or if you have a constant in front of your function, you can pull it out and put it as the constant times the derivative. So you can do combinations of longer functions now. So for this, you just take the derivative of each part respectively. There you go. Okay, that's not so bad. This one, I'm going to rewrite it first because I like the way that looks better than trying to do it myself. Alright, so g prime of x equals negative 4 times a half is 2, x cubed plus 6x squared minus 5. There you go. This one I'm going to rewrite over here. Y equals, alright, so we have x cubed divided by x to the 1/2. So it's going to be 3 minus 1/2, or 5 halves. So I'm going to write that as x to the 5 halves. Okay, then I have x squared over x to the 1/2. So that'll give us x to the 3 halves, and we have minus 3 halves x to the 3 halves. Next we have x to the 1 over x to the 1/2. Okay, that gives us x to the 1/2. So we have plus 7 halves x to the 1/2. And then 5 halves x to the negative 1/2. Alright, there's our function. Now our derivative. 5 halves x to the 3 halves minus, this looks like 9/4 x to the 1/2. Here we have 7/4 x to the negative 1/2. And then last minus 5/4 x to the negative 3 halves. Alright, now since we don't have a product rule yet, the only way we can do part D is to multiply it out. So we have 9x squared plus 12x plus 4. Hopefully I did that right. I think I did. Yeah, that looks fine. Alright, now I'm going to go ahead and distribute that. 9x cubed plus 12x squared plus 4x. And take the derivative. Y prime equals 27x squared plus 24x plus 4. There we go. So see, now you can you're building your stock of what functions you could take derivatives of. Alright, find the coordinates and equations of any of the horizontal tangents to the curve. Remember, horizontal tangents occur when your derivative or slope is 0. So we need to start off by finding the derivative. There we go. We have the derivative. We need to now find out where it equals 0. So I'm going to factor out a 4x. That leaves me with x squared minus 1. So that'll be 4x, x plus 1, x minus 1. That'll be at x equals 0, negative 1, and 1. So find the coordinates and the equations. So if I plug in 0, that gives me 2. If I plug in negative 1, that gives me 1, minus 2 plus 2, that gives me 1. And y of 1 looks like that equals 1 as well. Okay, so the coordinates of the horizontal tangents, they occur at 0, 2, negative 1, 1, and also at 1, 1. Okay, and the equations of the tangent lines, that would be y equals 2, y equals 1, and also y equals 1. So you got to make sure you answer your question. That's a really important thing. Once we master the polynomials, we can start looking at sine and cosine. They have a pretty close relationship. The derivative of sine is actually cosine, and the derivative of cosine is negative sine. You'll actually see that later with some of the other trig functions that anytime you have a co and you're taking a derivative, it's going to be negative. But we'll see that as we go on. All right, so if the derivative of sine is cosine, then the derivative of 2 sine is just going to be 2 cosine. Pretty easy, okay? This one we have f prime of x is going to be equal to 1/2 derivative of sine cosine. Not too bad. Some of these are actually easier than the polynomials. Oh no, we're combining them. Alright, derivative of x is 1. Derivative of cosine is negative sine. So you should memorize these, okay? And usually anything in a box you should memorize. There we go. For example 10, find the slope of the graph f of x equals sine at the origin and at that point. Okay, well, we know that the derivative of sine is cosine. So if we want to find the derivative or the slope specifically at the origin, we need to do cosine of 0, and cosine of 0 is just 1. Okay, for part B, f prime of 4/3 pi, the slope at 4/3 pi is going to be cosine of 4/3 pi. Okay, 4/3 is in the third quadrant, so it's going to be negative. And cosine of pi over 3, that reference angle, is 1/2. So there you go. Alright, so the derivative at a point gives the slope of the tangent line, or the instantaneous rate of change. One of the ways that we're going to use the idea of the derivative is going to be motion. And we had talked about position and velocity and acceleration and their relationship, how they're connected through derivatives. Now we have two different kinds of velocity we'll be talking about. Average velocity or average rate of change. It's just the slope. Think of the secant line. Okay, instantaneous velocity, however, is going to have to deal with the derivative, the slope of the tangent line. Alright, calculus textbook is dropped from a height of 100 feet. I'm sure all of you would like to do that. Its height is in feet is at time t seconds is given by that function. Find the average velocity over each of the following intervals. So all we're doing, average velocity s of 2 minus s of 1 over 2 minus 1. S of 2, I believe, is 32. S of 1 is 84. Over 1, so that equals negative 48 feet per second. So it makes sense that it's negative because the textbook, the height should be going down, so it's traveling downwards. Alright, so that kind of makes sense there. S of 1.5. So let's see, I think to show that setup, 64, if we plug in 1. I mean 1.5, and then 84 if I plug in 1. There we go, 1.5 minus 1. If you do that on your calculator, you're going to get negative 40 feet per second. And if you could see, we're trying to get closer and closer to 1 here. This one, if you use your calculator, you're going to get negative 33.6 feet per second. And this one, no big surprise, I'm sure. This one goes in your whisk. I want you to put it exactly what it is. Alright. Now, if those are the average velocities, as you see, they're getting lower and lower and closer to one certain number. If we do the instantaneous velocity at 1, that means we're using the slope of the tangent line, we're using the derivative. Okay, and remember, velocity is given by the derivative of the position function. So we have negative 32t. So the velocity at the instant t equals 1 equals negative 32 feet per second. How fast is the book traveling when it hits the ground? Well, first we should probably figure out when it hits the ground. So we have our our position function. We're trying to figure out when it hits the ground. So doing a little bit of algebra, 100 over 16, that could be 25 over 4. Oh, beautiful number, look at that. Plus or minus 5 halves. We can disregard the negative because we're talking about time here. So the time when the book hits the ground is 5 half-seconds. Now we need to find the velocity at 5 half-seconds, or 2.5 seconds. That'd be negative 32 times 5 halves, which would be negative 80 feet per second. So how fast is the book traveling? We could say that the book, to answer the question, the book is traveling, and it's traveling downwards. This is a little intro into what we're going to be doing for the rest of the class, okay? At a rate, you got to learn how to answer questions and explain your thoughts. The book is traveling downwards at a rate of 80 feet per second. Alright, into the last problem of this section. Piecewise functions are favorite. Find the values of a and b so that f of x is differentiable everywhere. A few videos ago, we learned that if you don't check the continuity, then it doesn't matter about the differentiability. So we got to work on that first. So let's check out what's the limit from the left side of 1. Okay, so we want the limit from the right side of 1 to also be equal to that. Right now it's equal to a plus b. So now we have this equation. We know a plus b must equal 2. So that might be helpful. Okay, we want f of x to be differentiable everywhere. We know we want our slopes to be equal. So if I look at the limit, actually the slope from the left side, we know that it's going to have to be -1 at x equals 1. Okay, because using our, if we have negative x to the first, we get -1 as our derivative. So that means that, and then the derivative of the bottom part is going to be 2ax plus b. So I'm going to need those two things equal. So now I have a system of two equations. I can change this one little bit because x is 1. So there, I have 2a plus b. I went over that kind of quick. We could talk about it in class if you need to. Let's subtract this. 2a minus a is a. B minus b is 0. -1 minus 2, -3. So a equals -3. Okay, so now to find b, a plus b equals 2. -3 plus b equals 2. B equals 5. There you go. So that's a nice problem for us to finish up with. Again, I went kind of quick, but if you need help, ask in class. Have